As discussed in the previous video, changes of state take place between solids, liquids, and gases. Kinetic theory looks at the behaviour of particles to explain why this happens, so let's start by looking at a solid. When a solid is heated up, the particles absorb energy, causing them to vibrate. Eventually, they vibrate so much that the solid expands and the bonds between the particles break, causing a liquid to form. If the liquid is heated further, the liquid will continue to expand, the remaining intermolecular forces will be broken, and the particles will gain enough energy to evaporate and turn into a gas. At the boiling point, the whole substance will change state from a liquid to a gas. Now let's take a look at what happens in the opposite direction. When energy is transferred from a gas to the surroundings, the particles lose energy and begin to slow down. The distance between the particles decreases, some of the intermolecular forces will reform, resulting in the formation of a liquid. If further energy is transferred, then bonds will reform between the particles and a solid reforms. It's important that you are able to explain in terms of energy why these state changes occur. Heating curves show how the temperature of a substance changes as it is heated from a solid. From this we can see where the changes of state occur. At the beginning, the temperature of a solid increases as it is heated up until it reaches its melting point. At its melting point, the line becomes horizontal, indicating the temperature does not increase during melting. This is because the energy is used to break the forces holding the particles together and turn the substance into a liquid. Once the melting process is finished, the energy transferred continues to increase the temperature of the liquid, which again we can see from this slope here. The temperature will continue to increase as heat is added until the boiling point is reached, which again is represented using a horizontal line. This is because the energy is used to break the remaining forces between the particles so that they can escape from the liquid. As a result, a gas will form, which is shown increasing in temperature at the end of the graph. It is important that you are able to interpret these curves and identify what change of state is happening at different points. Remember, during a change of state, there is no change in temperature. A cooling curve just shows the opposite and shows the changes of state which occur when a gas is cooled down. The slope lines show how the temperature of the solid, liquid and gas decrease, and the horizontal lines represent the changes of state, condensing and freezing. A cooling curve is just a mirror image of a heating curve. This question tells us that a gaseous substance is slowly cooled. Before you answer the question, it can be useful to interpret the cooling curve. Remember, the changes of state are shown by horizontal lines, and the sloped lines show where the gas, solid or liquid is being cooled. The question tells us that we start with a gaseous substance, so A must be a gas. As the gas is cooled down, it will turn into a liquid, which we know is condensing, and is represented by the letter B. The liquid continues to decrease in temperature, shown by C, until it reaches the freezing point at D and becomes a solid. Part A of the question asks for the change of state that occurs in region B, which we can see, for 1 mark, is condensing. Part B of the question asks at which point the substance will become a solid. This will be at the freezing point, which is at D, and again will score you 1 mark. This next question focuses on nitrogen dioxide. The question explains that when it is cooled, it forms a yellow liquid and then pale yellow crystals. The crystals are heated and the temperature measured every minute. Part A asks you to describe the arrangement and movement of the molecules in region A to B. So as we did before, let's start by interpreting the graph. Section A of the graph will represent the solid, as nitrogen dioxide crystals, as the question explains, are being heated. For part A of the question, you therefore need to describe the arrangement and movement of particles in the solid. From an earlier video, you should know that particles in the solid are arranged like this. The particles are closely packed together and arranged in a lattice, with the particles vibrating around fixed positions. This answer will score you 3 marks. Looking at the graph, the temperature of the solid will continue to increase until it reaches its melting point, which occurs in the region of B and C. You would also score the mark for freezing, as this is the change of state that occurs in the opposite direction. Once the substance is melted, the liquid will continue to increase in temperature, which is shown between C and D. In summary, kinetic theory explains why solids, liquids and gases change state by looking at the behaviour of the particles. You must be able to explain why a substance changes state by referring to the energy of the particles and the forces between them. You must also be able to label and interpret cooling and heating curves, which are used to show how the temperature of the substance changes as it is cooled down or heated up respectively.